Happy Wednesday morning. Was looking at graphs. So the basic idea is you're going to have what's called your toolkit functions. These are basic functions that you should know the shape of. X, absolute value of x, x squared, x cubed, square root of x, things like that. Use those basic shapes to sketch the graph of any function using what we call transformations. Three broad categories of transformations. You have translations, reflections, and then a stretch or compress. For each one, you have two types, a horizontal or a vertical. So a total of 6 transformations. Starting with the easiest, a translation. Get that up while I fix the master slides. Given a function f of x, a new function, g of x equals f of x plus k, where k is some constant, is a vertical shift or a vertical translation of the function f of x. All of the output values will change by k units. So a vertical translation is when you're adding some constant value to the output. If k is positive, it shifts k units upwards. If k is negative, it'll shift the absolute value of k units downwards. New function g of x equals f of x minus h, where again h is a constant, is a horizontal shift or a horizontal translation of the original function f. Notice that's what is now changing are the input values, not the output. If h is positive, the graph will shift to the right. If h is negative, the graph will shift to the left. And so again, a vertical shift results when there's a change in the output values. A horizontal shift will occurs when there's a change in the input values. Reflections. Given function f of x, the function g of x equals negative f of x is a vertical reflection of f. This is also called a reflection about the x-axis. And again, notice what's changing. We're multiplying the dependent variable, the output, by -1. G of x equal, I just copied the same thing. What's going on? The function g of x equals f of negative x is a horizontal reflection, also called a reflection about the y-axis. Again, notice what is being changed. It's the independent variable this time, the input that's being multiplied by a -1. So this next idea is actually fairly important. fairly useful, but is often overlooked, forgotten about. That's the idea of an even and an odd function. Function is even if for every x, f of x equals f of negative x. Even functions are symmetric about the y-axis. And the idea of symmetry is also fairly important. So if a function is symmetric about the y-axis, what does that mean? In terms of the graph.
Zero, like where x equals 0 is like the middle of the graph.
Well, that's true.
Well, like middle of the top point.
Yeah, that's true. But I would argue x cubed has the same property. The y-axis is the center, divides the graph in half, but that's not symmetric about the y-axis. Whereas x squared is.
So like the absolute value of the x values all have the same y value. And if it's like 2 and negative 2, they have the same y value.
Yes, that is true. What is that interpretation in terms of the graph? Right, so if you're given a graph and it's symmetric about the y-axis, how does it look?
To the left of the y-axis is symmetrical to the right.
Which means what? What does symmetrical mean? The same.
Just like a move.
They look the same. That's good enough government work. That would be symmetrical about the y-axis. Right, so that would be an example of an even function. A function is odd if for every x, f of x equals negative f of negative x. Another way you may see that written f of negative x is negative f of x. And kind of the same thing for even, you may see it written the other way, f of negative x equals f of x. In fact, those are the tests for even and odd. Replace x with negative x and see if you get either the original function back or the additive inverse of it. Odd functions are symmetrical about the origin. See if I can go on interesting functions symmetrical about the origin. Trying to avoid toolkit functions. Yeah, that's good enough. That would be symmetrical about the origin. Right. So the idea is, imagine, we'll go back to the even. Imagine that coordinate system as a sheet of paper, folded across the y-axis. If the curves match up, it's symmetrical. Right, so the curve on the right would lay perfectly on top of the curve on the left. Same idea with the origin, except you're folding it across the origin, right? So you're taking the top right corner to the bottom left corner. If the lines lay on top of each other, then that's symmetric about the origin. Which means those aren't the only two types of symmetry you have, right? You have symmetry across the x-axis. In theory, you have an infinite number of symmetries. In algebra, you study quadratic functions, which has an axis of symmetry. Right? X squared, obviously, the axis of symmetry is x equals 0, the y-axis. But if you shift it, the axis of symmetry also shifts. So it'd be symmetrical about that given line, x equals whatever it is, h. Is that what they use? The final transformation is also the biggest pain in the rear, and that's the stretching and compressing. Given function f of x, a new function g of x equals a times f of x, where a is greater than 0, and it's a constant, is called a vertical stretch or a vertical compression of the function f of x. Notice the restriction on a being positive. First off, if it's 0, it's blank. Because then your new function is just the constant function 0. If you're multiplying it by a negative value, then that's actually two transformations. The negative is a reflection, and then you have the stretch or compression of just a, which is why I'm just restricting a to be positive here. If a is larger than 1, the graph is stretched, I should say, stretched vertically. Oh, it's already up there, vertical. All right, it'll be stretched vertically by a factor of a. If A is less than 1, the graph is compressed by a factor of 1 over A. This is where your textbook is incorrect. They say it's compressed by a factor of A, which is not true. Right, if A is 1/2, if you're saying you're compressing it by a factor of 1/2, which actually means you're stretching it. And so we'd say it's compressed by a factor of 2. Which means you're multiplying everything by a 1/2. The function f of bx, again, b is greater than 0 and a constant, is a horizontal stretch or horizontal compression of f of x. And then same argument. There's a reason why it's positive. If you're doing f of negative something x, then it's a reflection first, and then worry about the stretch and compress. If b is greater than 1, the graph is compressed by a factor of b. If b is less than 1, it is stretched by a factor of 1 over b. Okay, so notice with the horizontal, the shift for horizontal works opposite of what you would think. If you have f of x plus h, you're not shifting to the right, you're shifting to the left. It's the opposite of the vertical. And the same thing here. It's the opposite of what you would think. If b is greater than 1, it is not a stretch. It is a compression. All right, so now let's examine the toolkit functions. First one, probably the easiest one, the constant function. All right, it's just a horizontal line at the value c. Domain is all real numbers. Oh dear. That is not how you write the range. Range is just a single value C. I know what they're trying to do with that, but no serious mathematician would ever write it that way. Next up is the identity function, which is just f of x equals x. Domain and range, all real numbers. Right, it's the line of slope 1 through the origin. And I know what that function is called, the identity function. Then you have the absolute value function. It's been a second. I know I'm charging for every now and then.
Got it.
Absolute value function has domain of all real numbers, range of all non-negative real numbers. Next up, the quadratic function. F of x equals x squared. Domain all real numbers, range all non-negative real numbers. By the way, every function of the form x to the n where n is even and greater than or equal to 2 looks pretty much the same. It just flattens out the bottom of the bowl, let's call it. We'll examine that when we look at the power functions when we study polynomials. Then we have the cubic function. F of x equals x cubed. Domain and range are all real numbers. And again, any function of the form x to the n where n is odd and larger than 3 looks similar. It just flattens out that middle part. Again, we'll examine that. The reciprocal function, 1 over x. Domain and range, all real numbers except 0.
Should it be brackets? Oh, yeah.
Next is the reciprocal squared function. Do you want to tell them? Or should I? How much of a bad idea that is? It's not a good idea to do that for instructor. You may not get partial credit on that. Again, there's only one person that might be worse than that's doing that to a police officer. You really don't want to piss them off. So they call this reciprocal squared. You may hear me refer to it as the inverse square, but it means the same thing. 1 over x squared. Domain, all real numbers except 0. Range, all positive real numbers. And for shorthand, I may write positive real numbers that way. Square root function. F of x equals square root of x. Domain and range, all non-negative real numbers. The difference between non-negative and positive. Non-negative includes 0. Because 0 is neither positive nor negative. Yet, oddly enough, 0 is even. Which I don't like. Why? Because 0 represents the lack of. So it should be neither even or odd. Cube root function. Domain and range, all real numbers. And look how similar that is to the cubic function. So, is that even, odd, or neither? Unlike with numbers, a function can be neither even nor odd. It doesn't have to be one of them. So would the constant function be even, odd, or neither? This is even.
Well, why is it even?
Hmm?
Why is it even?
Well, there's two ways. First, look at it. Isn't that symmetrical about the y-axis?
Yes.
So it's even.
Okay.
Also, what's f of negative x? C,
Mm.
which is f of x, which is the definition of even.
Yeah. Okay.
So the constant one is an easy one. What about x?
Okay.
Even, odd, or neither? Let's go and go with the first response, which is not correct. This one's odd. It's symmetrical about the origin. What about absolute value? That's even. X squared, even. X cubed, reciprocal function, 1 over x. It's odd. Symmetrical about the origin. Inverse square is even. Square root, that one's neither. Cube root is odd.
Next one.
There's a next one.
Okay, that's last one.
So we're going to sketch functions. First, the absolute value of x minus 1. First, try and describe what the graph will look like.
A line. Damn.
In terms of the absolute value function. True. Describe it in terms of the absolute value function. So how would you get it from absolute value of x? What's the transformation?
Oh, it's down 1.
So it's the absolute value of x shifted down 1 unit. And so vertex would now be at 0, -1. should be a 45-degree angle. No, the other side is pretty close. Should go through, for that side, should go through the upper right corner of every box. That means that the grid itself is off. Because that should be a 45-degree angle. Okay, well, there goes that idea.
So it's the same like calculator saying that.
Yeah, I think it's because I increased the size of the grids. Yeah, I mean, that's how it should look. But it has to go through those corners. Right, because it has to go through the point 1, 0. It has to go through the point -1, 0. So, there we go. Right, for reference, again, it's just a sketch, so it doesn't have to be exact. I'm just a perfectionist. That red is the original function. And so absolute value of x minus 2. Now what I'm going to do is, there we go, select that, and so again, start by trying to describe how you would get it.
What did you see translated to the on the x-axis?
To the left. Not to the left.
To the right.
To the right. And remember, it's the opposite of what you would think, because you're affecting the input, not the output. And so the new vertex would be there. It's not asked for, but what would the domain of that new function be? So I'll just write it as all real numbers. What about the range? -1 included? And so again, compare that to domain and range of the original. What about here? What's the domain? What do you mean by the same? What about the range? Absolute value of x plus 2 minus 1. So what's going to happen to the original? Left 2, down 1. Sure? Not sure.
Left one.
Well, I'm sure it's positive.
I was 100%
On a scale of 0 to 10, where 0 is unsure, 10 is absolutely sure. You risk all of your net worth on it.
What's the absolute value? It's not a correct.
So would you throw all of your net worth onto that insurer?
Yeah, dude, I'm putting the whole house on everything.
Good.
Yeah,
That's right.
I have 2 houses.
You're correct. I just got to keep going into this. Measure of your confidence level. So we went left 2, down 1. What's the domain? What's the range? -2 times absolute value of x plus 3. What kind of reflection? Vertical reflection, I agree. Stretched by a factor of 2, I agree. After the school closes. So we have a reflection, vertical, a vertical stretch. How far does it go up? What is it? How far does it go up?
3.
So there is a supposed order to the transformations. Okay. So generally it doesn't matter. I think the proper order is first a reflection about the x-axis, then stretching it by a factor of 2, and then moving it up by 3 units.
Yeah.
I think that would be the proper order. But it really doesn't matter. The new vertex will be at 0, 3, right there. This is where the stretch becomes. So it's being stretched by a factor of 2, and it's going to be upside down. That means all of the output values get doubled. Right, so try and visualize. We're going to ignore the reflection. Try and visualize the red and how it would look if you stretch it.
Would it be wider? You could go there.
The slopes would get steeper if you're stretching it vertically. So instead of going through each of these corners, it goes through every second one. So I have to go through this one, that one, that one. one. Oh, no, yep. That one. That one. And then same thing on the other side.
Why is it more narrow?
Stretching.
Oh.
So if that's 2 and -2, it would be the opposite.
If it was what?
If it
Yes,
was
I would.
2 instead of -2, would it
Yes,
be
I
the
would.
opposite? Would be that?
All the negative says it's a reflection.
Okay.
If it was 1/2,
Oh, right.
then it would compress.
Yeah, between 0 and 1, this is 5.
Because then all of your output values would be divided by 2 instead. So we do something like that. What's the domain?
Mm.
What's the range?
For a negative, that's negative. But it wouldn't be a bracket.
Yeah, how do you infinity work with that? It's not that.
What do you mean?
Like, can you just put a bracket on infinity?
That's not a bracket.
Do you ever put brackets on infinity?
Because what does a bracket mean?
That's it.
What point is infinity? It's not a point. It's just a representation of continuing on forever, increasing without bound. So you can't really include it.
Right.
So when we say stretch, the graph actually gets narrow. It alters all the functions, or is it just specifically absolute value?
So vertical stretch, and I don't want to say narrower, right? Because not everything's gonna kind of be like that, right? For instance, what about the absolute value, the square root of x? It's just a, what does narrower mean for that? Right, so you just have to kind of, what's going to wind up happening is the slope is going to increase. Let's put it that way. Right, so if you kind of imagine the steepness at a point, right, how steep it is, that will increase with a vertical stretch. New function. Right, so now we're dealing with the square root function.
Yay.
Start there. That point. Square root of negative x. What's going to happen?
You'll be on a negative input, right?
So what's going to happen?
You reflect across the y-axis.
Sketch, so something like that. What's the domain?
Negative infinity to 0.
What's the range?
Bracket 0.
Negative 3 root x. So what happens? Reflect over the y and stretch how? Stretch. Sure? On a scale of 0 to 10. How confident are you? It's a good answer, because you're but I'm not going to tell you which half. Reflection across the y-axis and a vertical stretch by a factor of 3. And that's half right. She said what, half? It's a vertical reflection which is across the x-axis. And then gets stretched by a factor. All right, so the vertex doesn't change. I'll just call it vertex for lack of a better word. But now all of your output values get multiplied by negative 3, right? So it's going to be upside down and then multiplied by 3. That goes there, and I don't have enough room. Oh, yes, I do. 2, 3, 4. That has to go down to 6 now. 6. And I don't have enough room to plot at 9, so that would be 12. Or, no, it'd be 9, right? 3 times 3 is 9. I do have room for that. So that'd be 9, 9. Right there. Something like that. What's the domain? What's the range? Open or closed? That's the other.
Close, yeah.
Close.
Bracket.
How confident are you? Because you don't sound very confident.
No, I'd say, like I said,
7?
okay,
No, that's only a C minus. That's a what? That is a 1.7 GPA. That's all good for you. I don't know what school considers a 1.7 good. Most grad schools, a 3.7 is borderline bad. For grad school, yeah, for your GPA. Especially engineering. You fall below 3.7 in engineering, they kick you out of the program.
That's the hardest thing to study.
Well, I would probably medical.
Yeah.
That's actually a tie between medical and law.
Well, yeah, medical law.
They're both pretty difficult, but for different reasons.
Because I think like 8 math classes not 8, but like
In grad school, you don't take any math courses.
for engineering.
It's just engineering courses.
You have to do math before.
Well, you have to do math in your undergrad.
Yeah, but like if you
At grad, no. Once you're at grad school in engineering, you're not going to do any of the math courses.
Oh, really?
It's all engineering courses. Now, you will be doing math,
Yeah.
but you don't have to take the grad math courses. I don't think. You might have to take one. You might have to take grad MEA, which is mathematical engineering analysis. But I don't really consider that a math course. It's a shame because that's right. One half square root of x plus 3. What kind of compression?
Running for 1 over 1 half, right? Yeah.
How?
How is that?
No, how?
It's like
What kind of compression?
like horizontal or vertical, you mean? Or vertical.
Vertical compression by a factor of 2, I agree. So you'd say here. Okay, so now I have 2. We have 1 there and 1 there.
Okay, right.
And which one is it?
The right side.
So you're right or my right?
Which one? His right.
Your left. Wait. Go it to the left. Go it to the left. To the left of the y-axis.
Let's just go with that.
Yeah, or horizontal shift.
So let's call that A, let's call that B. Is it A or B?
Maybe A, right? B.
And who says A? Who says B? Nobody wants, no, okay, so over half the class isn't voting, that's not big.
Is it upward?
That's really not good. Well, I guess it's a good thing this is not a democracy. It's a dictatorship. There's only one opinion that actually matters, and that's mine.
What's your opinion?
Say.
Yeah.
Now comes the fun part. Trying to sketch this graph.
Isn't that like over to outgoing?
So every output value gets cut in half. So it would normally be 1, 1, but now it's 2, 1, and then we have to move that over to left by 3.
Can you just go through
There. Normally it'd be 4, 2. Now it's 4, 1. Actually, is that right? No. That there's not right. It'd be 1, 1 half. Right, root 2 over 2 is not 1. It's about 1.2. Right, no, it's about 0.7. Root 2 is about 1.4. So that has to go to 3. 1, 2. So that has to go there. 2 is now 1. So that goes there. 9 is now 3 halves, which is 1 1/2, and that's divided by 3. That is there.
On like a quiz, would you make it so plot the points like really accurately?
Just has to be a rough sketch.
So if you just drew
It has to be relatively close.
you're just closer to the x-axis of the one that is the
And well, actually, it wouldn't matter because you make your estimate flip, not on the actual exam itself. If I have to give a graphing column, I might just print out graph paper for you. So I might print axes for you to use. Oh, this is going to be a pain. That's good enough. What's the domain? What is the range?
Wait, can you go back 5 seconds?
Can I? Can.
It's not that.
You were 4 seconds over. So the overcharge is $1 per nanosecond.
Wow.
You know which one you over?
You know how many nanoseconds are in 1 second?
Yeah, how many answers? I don't remember.
1 billion. Nanosecond is 10 to the minus 9.
What?
If I remember correctly, picosecond is 10 to the minus 12. Micro is 10 to the minus 6. Yeah, I think pico is 10 to the minus 12.
What's the smallest?
Huh?
What's the smallest?
Theoretically, there is no smallest.
Right.
In terms of what we would actually measure, what would be the smallest unit? Maybe the Planck. And Planck length is, I think, 10 to the minus 32 meters. I think that's the Planck length, something like that. So pi 10 to the minus 32.
Yeah, 100%.
So how are we going to get this?
I know they got the plus 2 on the outside.
Well, there's one transformation.
Reflection of the X.
There's two transformations.
And it's
That's disgusting.
stretches.
How?
30,
By what factor?
5, 30,
That's three transformations.
and it moves to the right on x-axis by 1.
And there's your fourth. So right there is going to be our new starting point. Goes about the x-axis, so it flips upside down. And every output value will be multiplied by, I don't want to say every output value. Every output, the output gets multiplied by 3/2 and then 2 added to it, is what this is saying. But I'll just treat this as my new origin and say every output value from there will be multiplied by 3/2. So increased by 1.5 times. All right, well. 1 be down here. Now multiply that by 3/2. So it's right here. Four over would be 2 down. Oh, that's nice. Times 3/2 is just 0. I like that one. 9 over 10 down by 3 multiplied by 3/2.
How did you get it? 1 times 1.5 equal less than 1.
So you go over 1 unit.
Yeah.
So that's going to be the new square root of 1,
Okay.
which is 1, right?
Yeah.
But it's negative. So it goes, I'm going to go down by 1 unit instead,
Right.
which is 1.
Uh-huh.
What's 1 times 3/2? Because I have to multiply by 3/2.
Is it 1 times 3 halves?
1 times 3/2 is 1.5, right?
Yeah.
Which is 3/2. 1.5 right there. All right, so plug in x equals 2. What's negative 1.5 plus 2 would be 1/2. Wait, what's going on?
Yeah, I think you're 10, bro. X equals 10 would be negative 2.
I think my analysis was wrong.
Yeah.
Should we do like 1/2 down?
So plug in 2, square root of 2, that's negative 1.5 plus 2 should be 1/2. It should be here.
Yeah, that's fine.
that's root 2. That's 2 times negative 1/2 is negative 3. Add 2, that'd be negative 1. That goes down there. 10 would give me root 9, which is 3 times negative 1.5 is negative 4. So it's just negative 3/2 times 3, which is negative 9/2, which is negative 4.5. Add 2 would be negative 2.5. Be right about there. So something like that. Domain.
Bracket 1 to negative.
Range.
Bracket 2 to negative.
So you can't write it that way.
Or negative infinity bracket 2.
Well, that's right. Okay. And so determine whether the function is even, odd, or neither. So determine, what you want to do is look at f of negative x. Right, if we're not looking at the graph. Absolute value of negative x. Can't say x. We don't know if x is positive or negative. just the absolute value of x. What is negative x raised to the 10th power? Is that the original function? Which means it's even.
Whatever the 3 dots, what you're saying. It's kind of
It's going to change the color if I need it. Replace x with negative x, and let's see what happens. So negative x raised to the 5th. Negative x raised to the 3rd. What is it?
actually, well, 2 dots.
Negative x raised to the 3rd. Would be negative x cubed, right? And that's just minus x. Is that the original function? What happens? That's what I'm saying. Does not equal f of x, so it's not even. Factor a negative out of it. Once you factor negative, is that now the original function? Which is odd. I'm using f. I should be using m. So use the f. R of negative x. Square root of 81 minus the quantity of negative x plus 2 squared. Is that R of x?
Yeah. Wait, no.
If we factor a negative out, R of X. So that's neither even nor odd. So z of negative x square root 49 minus negative x squared. What is negative x squared? Is that z of x? Do you recognize what that curve is? That's sad.
What was the question?
Do you recognize that curve?
Like the equation?
It represents a curve. A very common curve. The upper semicircle of radius 7.
Oh, yeah.
Oh, yeah.
Yeah,
Oh, yeah.
I was thinking about
I wasn't sure.
that. I know you got that one, right?
X squared plus y squared equals r squared is a circle of radius r. It's algebra 1. Maybe even geometry. So, you don't remember what you did 5 years ago?
Almost 14.
If you're going further into math, you should probably remember that relation. It's a very important relation. This one's really easy. It's definitely not g of x. And it's not even, is it all? Yeah, it's a very easy to see that that is negative g of x. F of negative x is not f of x. You should also be able to see that's not going to be negative f of x. So it's neither even nor odd. So have a good weekend. See you on Monday.